This is a 16 kilometer by 16 kilometer train which is running more than 300 frames per second in Godot game engine. In another word, this is a 256 square kilometer train. To give you an idea of how much big is that, let me tell you this way. It is 3.5 times bigger than map of GTA 5. Of course, it is not well designed like GTA 5, but for me it is important that this is working. And my PC can handle train big like this. We will think about the design later. It is a while which I am working on my train system, and finally I have something which can be used. I released the alpha version of my train, and in this video I will show you how you can make a train similar to this. Well, first go to the GitHub repository link which is in the video description. This library is wrote in GD extension. You can build that by yourself, or you can download the latest release which I already built. As this is the alpha version, I built only the debug version of this library for Windows and Linux. Unzip that and then put the add-on folder inside your project. After adding this, it is possible that this will crash the first time you want to use that. Don't worry, just open that again and hopefully this will work. Okay, now go inside project setting and activate mtrain plugin. Well done. Now we should import our train. Please watch this part of this video carefully because that could save you a lot of time. First of all, you should choose the right format of image. So what is the good format of image? 8-bit images are absolutely not good. Your image must be 16-bit or 32-bit at least. Second important thing is you should use OpenXR format or raw 16-bit image format. But if you ask me which one among of those above is better, I would say raw 16-bit. Even with OpenXR, I saw sometimes some artifact in my train. As I improve this train system, I will add support for other image format like raw 32-bit image format. So the question now is, where should I get my height map? There are a lot of software. The free one is Blender. Other than Blender, there is L3DT, which give you up to 2K height map free. Also, other software which I can name are Machine Word, Gaia, Word Creator, and so on. And let me tell you this, even with this plugin, is really easy to add the functionality to generate train. I will tell you later in this video why. Okay, now that you know what is the correct format for height map, let us discuss about the correct dimension for train. The first thing that you need to do, you must decide what is the horizontal scale for your train. What I mean by horizontal scale is how many pixels for each meter. And that is really depend on your game which you want to make. If you make a flight simulator which you are very far from the train, 1 pixel for each 8 meter or even 1 pixel for each 16 meter is enough. If you make a top-down game, 1 pixel for each 4 meter or 2 meter is enough. And if you make a first-person game which your player is close to train, I would say 1 pixel for 1 meter or 1 pixel for half meter is good. Horizontal scale also depends on the type of the train. If you make a mostly flat games which has some hills on that, even for the first person games, 1 pixel for each 2 meter is enough. The demo train that you can see here is 1 pixel for 1 meter. And I believe that is enough for me. You can see some part of the train has some edges which seems to be not good. And that is because this height map is not smooth. If you design your height map smooth, even this will look good. Also, in many open world games, they cover the part of the game which has a strong slope with rock or other stuff. So now you decide what is your horizontal scale. Let us discuss what is the correct dimension for the height map images. This part is really important, and I wish someone else gave me this information before. This is a train chunk, and depend on level of detail of train, we have different chunks. This chunk is 4 meter, and as you can see, for each meter there is a vertex. So what height map resolution I should use for this train? Well, one might say a 4 by 4 pixel height map. This will work, but this has a problem. Because if you see here, we have 5 vertex in each direction. And I provided 4 height map pixel, or in another word, 4 information. So what is the correct height map? Actually, we should use a 5 by 5 height map resolution for this. Okay, I did another thing in my train, and I divided my height map into different regions. But please note, dividing height map, it is not like dividing an image. Let me tell you why. The chunk on right side is 4 times bigger than the chunk in left side. Now imagine we want to divide the chunk on right side and create that chunk with 4 of the small chunk. Here I just highlight the edges which are common between two train chunks if we divide this big chunk. As you can see here, these edges cut the height map pixel in half. And that is really correct because these edges should be in the same height, and if not, there will be a gap between two train chunks. So their height map pixel value should have the same value. So here how we can divide this chunk to 4 small chunks. The bigger chunk has height map resolution of 9 by 9 pixel. And we create a small chunk with height map resolution of 5 by 5. Now these 4 chunks in total have 10 by 10 pixel of height map. But the important point is that they share the same pixel in edges. Or in another word, the pixel in edges should be same. So the edges will have no gap in them. Another important thing is that we should modify the UV coordinate so everything will match together like this. So what we learn here is that the region size and height map size should be in the power of 2 plus 1. And this is really important. Well, now that we know what is the correct image dimension for our train, let's import our train. Just go inside Project, Tools, mtrain importer. As you click on that, a window will appear which here you can import your height map. If you want to test this, I just put a link of 8K height map image in the video description so you can test that. But for the purpose of this video, I will import a small train. Okay, select the path of your height map. Here I just select a raw 16-bit image height map. Because the raw images has no header, sometimes you need to specify the width and the height of the height map, so you will be able to import them. But in the case that width and height are the same, it can calculate automatically the width and height by itself. Okay, after that, you should define the region size. For example, here, my train is 1025 by 1025. So I want to divide this in 4 parts. So I put the size of each region 513. With this importer, you can import other things related to train like a splat map, light map, and other stuff. But here, because we import height map, just check is height map. As you do that, it will automatically set the uniform name height map, and also 2 other options will appear. One is max height and other is min height. Just set the max and min height and create a data folder for train and select that, then click on import. This will import your train height map. If you go inside data folder, you can see it's divided the height map into 4 parts. And these images are black or red. That is because the value of these height map images are more than 1 or below 0. So this will be shown in this way. Also, this importer will take care of the shared pixel in edges. One other important thing is that we import our height map as image, not texture. Basically in Godot, images are located inside RAM memory and can be accessed by CPU or by code. But textures are located in GPU memory and cannot be modified easily. What this mtrain plugin do is that it keeps the information for train inside RAM, resize them with a special algorithm based on the distance to the camera, and send them to the GPU memory. Well, now let's create our train. Create a root node and then add mtrain node. First, copy the data directory to data directory property. Now you should do some calculation and set the correct number here. This plugin is still in alpha stage, so it cannot handle error yet. So for now, if you don't put the correct amount here, it is possible that this will crash. First thing that you should note is that what is the base size of the train grid. This is really important. In this case, it is 32. This is the base size in train, and everything in train will calculate based on this. Basically, this is the smallest train chunk size. and this will determine the grid unit. Other important setting is edge scale or horizontal scale, which is in this case 1. This means for each meter we have 1 pixel. After that we should set the region size. In this case, each region size is 513 pixel by 513 pixel. 1 pixel is for shared pixel, so each region is 512 meter by 512 meter. Just take a calculator and calculate the region size in grid unit. In this case, our grid unit is 32, so I divide 512 by 32. The result is 16, so I put the region size to 16. Max range will determine up to which train chunk you are able to see. This does not matter too much, and also you can change the max range during the runtime. Next thing that I want to change is the maximum horizontal scale to something else. Because this is a really small train, so I put the maximum horizontal scale to 8 meter. So this means that LOD0 is 1 vertex per meter, LOD1 is 1 vertex for 2 meter, LOD2 is 1 vertex for 4 meter, and LOD3 is 1 vertex for 8 meter. Now just here set the correct amount for LOD distance. I put the LOD0 distance to 4, which means up to 4 grid unit LOD0 is active. And in this case, LOD3 is everything further than 10 grid unit. After that, create a shader material for this. And for the shader code, I put a start shader code inside add-on folder. So choose that shader code. I will explain about the shader code later in this video. One other important thing which I forgot is to set the train size. Here we have a train with a size of 1024 by 1024 meter. Just divide that to the base size and set the correct train size. Recheck if everything is correct, because if you put this number wrong or you don't set the material, this will crash, because I did not implement a good error handling yet. If you are sure everything is okay, just click on create grid. This will create your train. Now let's take a look at the shader code. But before I explain about shader code, let me tell you this. The material inside mtrain is just a blueprint for other material in each region. Basically, this material will duplicate it for each region, and each region will change some uniform inside this material. This uniform below must exist inside each shader code, because each region does not check if they exist or not. They assume they exist, and if they does not exist, your train might crash. mtrain height map is the height map of your train. mtrain normal is the normals of your train. Basically, you should correct the train normal with this texture. And I don't think it is possible to create normal in shader code, because we divide the height map to different regions. And I think it is impossible to do that in shader code, because at some point in some edges you cannot make a correct height map. Also, this normal will give you much better result. Normals in mtrain plugin are generated by CPU each time you create train. I increased the speed of the normal generation 10 times by using multiple CPU threads. But anyway, that could take some time if your train is big. Region world position is the position of top left corner of each region in the world. Region size is the region size. In this case, it is 512 meter. Region A and region B are some number for correcting the UV coordinate. And down here, I just calculated the correct UV, and also I just set the height map and correct normals. Each time you create train, you generate normals. You can also save them if you want. Just check save generated normals. Okay, that did not work. Let me restart Godot. Now it works. As you can see, this will save the normal inside data directory. This will help to load faster if you have a fast speed hard drive like SSD. I personally use this during develop time to load faster my train, and maybe in release game I remove this to reduce the exported game size. Okay, now let's see how we can add another texture to our train like a splat map. A splat map is a texture that is used in train to tell where to draw each texture. For example, where to draw the sand and where to draw the green ground train and so on. So let's import that. I just created a dummy texture to show you how you can do that. Go inside project, tools, mtrain importer. Here just select your splat map texture. Your splat map also should have the same dimension as the height map, in this case 1025. So select that, set the region size same as before, set the uniform name, in this case I named that splat map. For a splat map, I like to change the format of it. If you go inside Godot documentation, for image class, you can see each image format is associated with an integer number. You cannot select format with compression, but you can select everything else. In this case, I choose RGBA4, which is associated with number 6 in this case. So I set my image format to number 6. Then select the data folder and import a splat map. Inside your shader, just add a sampler 2D. With the same name, just add mtrain prefix. Now you can use your splat map in your train. Next thing that I want to mention here is how to import already tiled train. In many cases which your train is huge, you cannot import them with one image. You have to tile them before importing. Also, most of the train generator software do this. So here I will show you an example. As you select a tiled image, mtrain importer recognizes that automatically. And as you can see, some option inside importer has been changed. First one is flip X and flip Y. This height map Y direction is reversed. So here Y is checked automatically. In tiled mode, your region size is determined by tiled image dimension. Also, tiled image must be in power of 2. mtrain importer will automatically make shared pixel in edges. Also, for tile mode, you need to specify a temporary directory. mtrain importer will use this folder to import the images, and then it will use these images to create a shared pixel from them automatically. Okay, that was about how you can import tile train. Now let's see what other control you have over train. Here you have update chunk interval. This will determine the update train chunk duration. But please note, this will not guarantee that a train will update exactly each 0.2 seconds. It will check if the train is finished update, it will start another train update. And if not, it will continue running and it will check again. Basically, train update is done in another CPU thread. You can also change this interval time as you want. Also, you can deactivate that. Basically, you can do the train update manually. Maybe your player is inside house, so why wasting energy to update the train? Here we have another interval too, and it is called update physics interval. Basically, mtrain calculate two different things in two different CPU threads. One is updating chunks and one is updating physics collision shape. And these two things running separately in two different CPU threads at the same time. Here we have another variable and it is called physics update limit. Basically, each region create a collision shape for itself. This will determine up to how many regions around player physics collision shape should be generated. Okay, that was about thread calculation for train chunks and physics. Now let's see what other functionality our train have. Let me create a script for train. And before adding anything, let me add a camera. For now, if I run my game without a camera, it will crash, but I will make that correct later. After that, I attach free look camera script to my camera. This is really cool script which is in asset library, which help you to move around the camera in runtime. Train will not create itself automatically for now. You just need to set create grid to true. Then when you run the game, this will create the train. Because all the images for height map and normals and the splat map and everything else related to train is in the CPU side or inside RAM, you can access them, you can also change them. For example, the way you can access the height data is by calling this function, get height by pixel. But one important feature of this function is that you should not worry about shared pixel. By calling this function, you think that all of the train is a big image, and that image is not divided at all. In this case, all of our train without shared pixel is 1025. But as pixel index start from 0, so you can access pixels from 0 up to 1024. You can also set pixel without worrying about shared pixel. In this example, I can set the pixel at 512 and 512 with some number. If you notice, this pixel is shared between 4 regions. mtrain automatically change the height value inside all of the 4 regions. You can do the same thing with other train image like normals. But first you should take the ID of that image and then use that ID to read or write to that image. By this, I think it will be very easy to add a height map editor here. Even make changes to that train when game is running. One last thing, what is the limit of this train? Of course, you cannot build the infinite train with this. Right now, the only limitation is the amount of the RAM memory. For example, you can see here the amount of the RAM memory usage for a 16 km by 16 km train is around 4 GB. I solved the problem with the GPU memory usage by resizing the train texture further away from the camera, but all of the information for height map, normal, splat map must be inside RAM. You can avoid a splat map by generating texture with normals and height map, but at least height map and normals should be on RAM memory. Of course, there is also another story of loading height map from the hard disk in runtime, which for now I don't have plan to work on that, at least for now. And finally, let me know what do you think about my train system in comment section. I hope you enjoyed this video, and till the next video, have a good time.